Okay, this video is for the Module 10 and 11 review. So we're going to be combining the things we've learned in the past few units about graphs and patterns to take a test tomorrow. So we're going to do some reviews. These problems are very similar to the ones that you will find on your test tomorrow. So if you have any questions on these, be sure to let me know and we can set up a time to meet before you take your test. So this one tells us that Mr. Garcia can estimate the distance in miles he will drive D. So the distance is D, given a certain number of hours T using the equation. So 60 of the time, so he can do 60 for every probably hour of the time equals the distance he can drive. So here we have T, here we have D. So this just goes opposite here. So if I was writing this equation, I would probably write 60T equals the distance he can drive. So every time it's been an hour, he can drive 60 miles here. So the first thing we're going to do is plug in this, and this is representing T. So we're going to do 60 times 0.25, and that will tell us how far he can go in 2.5 miles. Let's go ahead and pause the video and try that. So here is 0 and 30, then placeholder 0 and 12. So it looks like 1500, but don't forget we have this decimal here. So after 2.5 hours, he can drive 150 miles. So I am noticing a little bit of a pattern here, but that does not mean that they made this go in a set pattern. So we know tables, we can just pick any number. We just need the same pattern going across here. So this time we want to do 60 times 5 to get here. So we can see here, this one's already done for us. 60 times 10 is 600. So 5 times 60, 6 times 5 is 30 with a 0. So now this time we need to work backwards. So let's look at the one that was already completed for us. D was 600, and then we had 60T equaled 600. And we wanted to get the time all by itself. So we need to do the opposite of times by 60 and divide by 60. So this cancels out, so we're left with T. And these cancel out. 6 goes into 60 10 times. So it looks like when we're going backwards to find the time that we need to divide by 2.5. And we can't, or sorry, not divide by 2.5. I looked up here. I didn't go up high enough. Our equation is divide by 60. So this first one is 390 divided by 60. I notice they both end in 0, so I can actually cancel those out. So 6 goes into 39 6 times, which is 36. 3 left over, bring a decimal down and a 0. And 6 goes into 30 5 times. So after 6.5 hours, they went 390 miles. Then our last one, going backwards, so we have 60T equals 180. So we want to divide by 60 on both sides. So 60 goes into 180 3 whole times. So after 3 hours, they drove 180 miles. So every time you just use the equation, plug in what you know, and go back and forth to fill out the chart. So this time we want to write an equation. So we've got X, we've got Y, and we've got to figure out what is the pattern to represent this graph. So I like to write a table out. Sometimes I can't see the pattern looking at the chart, but I can see X and Y. I can see the pattern when they're lined up a little better. So I went over 0, up 5. So 0, 5, over 1, up 6, over 2, up 7, over 3, up to 8. So that should give me a good idea of what my pattern is. So I want to ask myself, how did I get from 1 to 6? So I could multiply by 6, but if I do 2 times 6, that is not 7. So we know it's not multiply by 6. So how else can I get from 1 to 6? So it's getting bigger, so we could add on 5. So let's check. 2 plus 5 is 7. 3 plus 5 is 8. So every time we were taking 5 and adding it on to this number here, which is represented by x. So 5 plus our variable is x equals y. So we can plug any number into x, add on 5, and that will tell us y, and it will keep going in that straight pattern there. This problem tells us that Frankie reads 32 pages of a book each night before he goes to sleep. So this is the total he reads, but it's not the total of the book. Just keep that in mind. We may or may not need to know that. So we want an equation that represents the number of pages Frankie reads in n amount of nights. So this is for one night. Every night is 30. He does 32 pages. Well, I guess I shouldn't call that n. So that's for one night. So if he reads for one day, for one night, how many pages did he read? 32. We did one night times 32 equals 32. Okay, what if Frankie reads for 2 nights? After 2 nights, we would multiply and get 64. So 32 is our constant. That stays the same. 32, and we're going to multiply by the nights, which is n. 32n is the best way to write that, equals the total number of pages, p. Now we can use this equation to see how many pages Frankie read after 8 nights. So we want to plug this in where n is. 32 times 8 will give us p. So go ahead and pause and try that problem there. So 8 times 2 is 16, 24, 25. So after 8 nights, if he keeps up his pattern, he's read 256 pages. So if we were graphing this, we would go over 1, up 32, over 1, up 32, over 1, up 32, and we would be creating that straight line to show that Frankie has a constant unit rate. Let me move my head here. Okay, so a hose can be used to fill a swimming pool with water at a rate of 4 inches every hour. So we've got 4 inches in 1 hour. So here's our inches, here's our hours. 4 inches, 1 hour. Write an equation to relate the number of inches of water in the pool, y. So y is our inches. To hours, it takes x. So if that is a little confusing, let's maybe come down and use some of our tables and charts, and we can come back and figure out what is happening here. So we can see right here, we have 1 hour was 4 inches. 1 hour, 4 inches. 1x is a y, is 4 y's, I should say. 1x is 4 y's. So if it's been 2 hours, they should get, what do you think? So every hour was 4, so now it's been 2 hours for 8. So now, if it's been 2.5, 2.5 times 4 is, here's 8, 9, 10 with a placeholder. So after 2.5, they'll get 10 inches. So we're going to go backwards this time. So we need to think about what's happening. So to get from 2 to 8, we times by 4. 2.5 times 4 is 10. 1 times 4. So every time we're taking the x and we're multiplying it by 4. So 4 x's equals a y. We could also take a fourth of y, and that could equal x. These are opposite and equivalent equations here. So, or we could take y, we could also do y and divide it by 4 to equal an x. So all of these mean the same thing. So let's go ahead and finish filling out our table. So we know every time we have y, so we have 4x equals 2. So we need to divide by 4, divide by 4. 2 divided by 4 is a fraction. So we can simplify it. Half of 4 is 2, so this is half of an hour. Our next problem, we know we can make 4, takes 4 hours to do 4, so 4 x's equals, this time is 6. Going to divide by 4, divide by 4. 4 goes into 6 one whole time with 2 fourths left over, 1.5. So every time when we're going from x to y, we times by 4. When we went backwards, we did the opposite, divide by 4, since those are reciprocal in operations. So now it wants us to graph these. So we're going over half, up 2. Over 1, up 4. Over 1.5, up 6. Over 2, up 8. Over 2.5, up 10. So since this is a constant rate of 4 inches every hour, we can see that it's going to make that nice straight line there to show over half an hour, up 2 inches, over half an hour, up 2 inches. So that unit rate triangle is the same every time. So figure out what is happening every time to get from X to Y. That's your pattern and your equation you want to use to fill out your table. Then remember on X, we always go over, then up. Now we are going to graph a polygon, so a shape that has these vertices. So we always use our X first to go over, then up or down. So this one wants us to start right at 0 and go up +2. So here's our first one. Now we are going over 5, down -3, 1, 2, 3, -2, -4, -2, -4, and then we're going over -4 and 0. So then I can go ahead and connect all of these. So this is just a quadrilateral. It has 4 sides, 4 angles, but there's no parallel sides. So this is just a quadrilateral. Lily uses the coordinate plane below to make plans for building a fence around her rectangular garden. So when I'm hearing fence, I'm thinking perimeter. So perimeter just adds up around. She knows that the length of one side of the fence will be -6, 1, 2 over 3 up 1. So this is one side of her fence. The perimeter is a total of 24. Where could Lily build the fence? So we just have to do a possible location. So the first thing we need to do is we need to figure out this distance here. So to go, here's 1, 2, 3. And to connect this side here is 6. So we have 6, we have 3. So that's a total of 9 units. As we're building this fence, that means she's going to have another side of 9 units because it's going to be a rectangle. So if the top or the bottom is 9, the other side has to be 9. So she has 2 sides that are 9. So let's see how much we have left. 9 plus 9 is 18. And her total is 24. We're already at 18. How much is left to get from 18 to 24? So 24 minus 18 is 6. But now remember, this 6 is not just the answer. We've done 2 sides so far, but a rectangle has 4. If you just do 6, that's going to make a triangle. We need to take 6 and divide it into the 2 other sides of our rectangle. 6 divided by 2 is 3. So we could either go up 3, 1, 2, 3, and we could put it here, and 1, 2, 3 here. And my rectangle could look like that. So here's 9, 18, 21, 24. Or I could go down 1, 2, 3, and over, and then connect 1, 2, 3. So here I'd have 9, 18, 21, and 24. So either of these would work as a possible answer. And it just says a possible answer. So don't put both of them because it might not recognize what you're doing. It's just saying you can either do the green one or you can do the red one. So, right, she only can make her garden 24 units. If she did both of those, that would be double the fencing that she has. This map shows where 5 friends live. So Matthew, Andre, Pablo, Ricky, and Doug. Every unit on the coordinate plane represents 2.75 kilometers. How many kilometers is it from Andre to Ricky? So I can see Andre and Ricky are in this straight line. To get to Andre's from, we'll call this Main Street, is 2 units. To get from Ricky's house from Main Street is 4 units. So their total distance here is 6 units. So 6 units, but every unit is 2.75. So we need to take 2.75, that's 1 unit, and we want 6 of those. So go ahead and pause and find out how many kilometers it is from Andre to Ricky. So here's 30, 42, 43, 44, 45, and 12, 13, 14, 15, and 16, but we have 2 decimal places. So it is 16.5 kilometers to get from Andre to Ricky's house. This time we are going to reflect this point over. So if I'm kind of thinking, here's my grid, I need to go over 10.5, up 9. So I can see it's in quadrant 1. Remember 1, 2, 3, 4. And we want to go over X. So X is here. So we're going to flip over here into quadrant 4. Quadrant 4. So where is our new point? So we still need to go over the same amount. We're flipping over X, so we want to keep X the same. So our new point is still 10.5 over, but this time instead of going up 9, we want to do the opposite and go down 9. So over 10.5, down 9, flips it over X. The one you're flipping over stays the same. The other one becomes opposite. So now we need to find the distance from here to here. So it was up 9 for this one. I'm going to switch my colors. So we went up 9. This one went down 9. So we need to put those together since they're in different quadrants. 9 and 9 makes 18. Okay, and here we have this coordinate plane, shows the location of 4 islands in the Pacific Ocean, and I'm losing my light. So which island is located in quadrant 2? So here we start at 1. We work our way around to the left. There's 2, 3, and 4 is the IV. 5 means V. So 1 less than 5 is 4. So which island is in quadrant 2? Quadrant 2 is negative positive. Island A is in quadrant 2. Now we need to find C. So go ahead and see if you can figure out the coordinates for island C. So I'm looking, here's island C. We have to go over positive 3, and then we're going down negative 5 here. Our next question asks if each unit on the coordinate plane is 150 miles. So every unit is 150. How many miles to get from A to D? So they're on the same line here. So to get from we'll call this the equator. How about that? So the equator up to island A is 5 units. And the equator down to island D is the absolute value of 4, or negative 4, which is 4. 4 units here, or sorry, 5 units here, 4 units here makes a total of 9 units. But they're not just 9 miles away. Every one of those units is 150 miles. So we want to take 150, multiply it by 9, and that will tell us how many miles the islands are away from each other. So pause and go ahead and try that. So here's 0, 45, 9, 10, 11, 12, 13. So they are 1,350 miles apart from each other. Okay, that is it for our review. So if any of that is not making sense to you, please let me know, and let's set up a time that we can meet together to do some more practice before you take your test.